Welcome to another episode of Connecting the Lines. Today, we're diving into a world where machines and humans coexist. No, it's not the future. It's the world of today's high-tech manufacturing plants that utilize industrial robots and advanced automation. We'll explore the systems, the business cases, philosophy, and the overall impact of today and tomorrow's smart factory. And joining me to discuss these topics are two people who have a combined 60-plus years of manufacturing operations experience. Doug Cozzens, over 30 years of manufacturing, engineering, and operations experience. A global continuous improvement leader with a focus on safety, quality, engagement, productivity, materials, process engineering. You established and currently lead PLP's Global Operating Systems Initiative, which is to align best practices across 20-plus sites. Extensive international operations experience, including extensive travel. I remember I talked to you one time about how much you travel. I think it's something insane, like hundreds of days a year or something.
Yeah, it's insane. 30 to 40%.
Okay. And a master's degree in engineering from Michigan Technological University.
Yeah, it's way up in the Upper Peninsula.
Okay. And then we have Alwin Duckham. 30-plus year career in engineering, 10-plus years of experience working in manufacturing technology, also extensive international experience in manufacturing, engineering, quality standards, continuous improvement, and supply chain. And you currently oversee PLP's Advanced Manufacturing Group.
Yeah.
Can you explain to me what the Advanced Manufacturing Group is?
Yeah, so we started the Advanced Manufacturing Group about 2.5 years ago. And the thinking was, what can we do to enhance PLP's competitiveness in terms of new technology, automation, doing things differently than we have done in the past years, just to kind of give us a kick start or boost in terms of doing things differently, improving our processes, automating things, look at things that we haven't looked at previously in terms of the latest technology out there. So some of the things, for example, is IoT, robotics, automation, Internet of Things. Those are kind of the buzzwords you hear around. So it's focusing on those kind of new technologies.
Okay, great. So that leads me into kind of the initial question here, which is we're talking about automation and robotics. So I just want to kind of set the stage there on what those are when we're talking about those terms. So I guess in my interpretation, automation would kind of be the broader term that incorporates all those things that you mentioned, robotics, IoT, and stuff like that. And robotics would actually be using, a machine to perform, I guess, what would be a human function. And maybe you guys can define those better.
Right. Well, going back to the original thought process, just to give some kind of separation. So we kind of really focus on the industrial side of automation. I know you get industrial in terms of flows and processes, very much focus on the industrial side. So if I had to differentiate between automation and robotics, we kind of learned this the hard way. We thought, let's recruit as many robotic engineers as we can because that's what we need. But robotics is just a portion of the bigger automation. In fact, that's the easy bit. Programming the robots, teaching them what to do, scripting, the code to run them is the easy part. So the broader sense of automation is actually, I would say, machine design, where robotics is a subset of that broader topic. So very, very soon in the process, we realized, okay, we don't actually need robotic engineers. We need machine design engineers, control engineers, mechanical engineers. When it comes to the peripheral jigging, fixturing, and such alike, that's like the critical part in terms of automating something. The robotics is just a subset of the broader automation topic. So we learned that the hard way in the early days, that we need machine design engineers, control engineers to basically piece everything together.
So when you say machine design, is that kind of like building something from the ground up more? And then robotics is kind of like your final point in there? You're taking all that knowledge and then applying some kind of robot to do that.
Yeah, so the robot is something we buy from a third party. We have basically standardized to a particular brand that we use, at least in the USA. So we would buy that robot as a complete unit and then obviously code and script whatever we wanted to do. But in terms of the machine design, for example, we may have a cell that has 4,000 unique design components, and then we have the robot that sits within that complete design. So each and every component that works together within the complete design is where all the hard work gets done, because, like I say, there's up to 4,000 uniquely designed components that fit together to form the assembly. There's safety, there's controls, there's all kinds of things that have to be considered, and the robot's just the final bit that moves the product into position where the fixturing, whatever, takes care of the rest.
Okay. So maybe one of you can kind of walk me through an example of an automation project, either real world that we have, done, or how that process would start. And, you explained it a little bit, but just what is an example of a typical automation project?
Yeah. So I think of it very similar to Alwin in that the robotics are more off the shelf, prepackaged, whereas the automation is more custom, where you're designing the actual system. It could include a robot, but the automation is the broader system, as Alwin mentioned. One example, well, there's plenty of examples, but one example is one that we did in our Thailand operation, where the team came together and designed their own gantry system for extracting plastic injected products from the machine. And that saved a lot of time and consistency and quality for that product. It was a spacer cabler as well as some insulators they were creating on that machine.
So how long do these projects usually take to implement? I would expect, it can vary, but I expect it's fairly long, because if you're talking about a lot of like investigation and quality checks and all that kind of stuff. So on typical, like, how long does it take?
In terms of the whole journey, there's obviously identifying the need, and the need may be based on quality, it may be gain capacity, it may be reduction of cost, may be a safety. So those are the four pillars we use to assess a project, and it's our customers are basically the plan. So they'll come to us and say, we have this need. We think that automation or robotics may help with that need. Like I say, whether it be cost, trying to gain capacity, solving a quality problem, or solving a health and safety problem. So that's a starting point. Basically characterizing in one of those buckets, what type of project it is. And then the second part of that is, are we going to do the project ourselves within PLP, or are we going to use external integrators? Because we do have a team that works on these things, but of course we cannot do everything ourselves. So we do try keep a balance of 50-50. We do 50% of the projects in-house, obviously to protect our IP, the stuff that's like off the shelf. For example, a machine tending robot is something that you probably could shop around and find something and find an integrator that will work, who's had experience working with something similar. Unfortunately, with PLP, we have very unique set of processes that we operate. We have very unique machinery. So if it's off the shelf, like a milling machine, extruding line, or a plastic injection, one of the standard processes, we'll probably go to a integrator to do the project for us. But a lot of the time, if it's PLP specific process, we'll do that in-house. And then typically what happens is we'll categorize and type a project, like I said, those four pillars, and then we'll create some concepts of what we think the solution should look like. Sometimes we even have to do like prototypes to prove a concept, a new way of grabbing the product, picking up the product. So we'll actually create a pilot or a prototype to test it out. Once we have some kind of faith in the concept we want to look at, and then obviously we'll start engaging with our customer base, which is obviously the operations, and say, hey, this is what we're thinking about doing. This is a way we hope to design the product. We get the buy-in from them, speak to the operators, speak to the guys on the floor, so we understand what their requirements are, and then from there start a formal design process. And then the downstream process is pretty much project management. Once the design is done, there's project management, speaking to the vendors, sourcing the machine components, assembling everything together, testing it. Very important part of the whole supply chain is doing the commissioning and make sure it's safe launch, everything is done properly. Whatever the original scope is, we make sure there's a specific cycle time. For example, if it's a speed project, we obviously ensure that we meet those initial scope of works which is defined in the beginning of the project. And so it's the handoff, the validation that's important to close the project out. And then simply what we do, we hand the production personnel a packet, which basically includes the drawings, the maintenance details, the SOPs, safety, risk assessments, and that gets handed over to production. And then we go back and then do a financial audit to make sure that we've obviously whatever justification that we put out initially, we go back and validate that we are achieving the savings. If it's a quality issue, we go back, make sure that everything closes out properly.
And if I could just build on that, to address the timing, it depends on whether we're doing a replication process, a replication automation application, where we've already proven it in some of our other sites and we're just basically copy paste, versus some of the innovation that Alwin mentioned, where it requires a lot more development work, a lot more experimentation, that those can take up to a year potentially. But some of those replication projects we can implement pretty quickly.
Yeah, that's a good point.
So you both mentioned kind of the ROI on this. So I think maybe one misconception is that it's strictly financial implication based, but you're saying there's many other factors that could be why we might employ automation.
Depends who you ask. If you ask the financial guys, they'll say.
But I think Alwin covered it a little bit earlier, is that definitely, number one, if there's a safety issue that we can address, ergonomics especially, where there's heavy objects that we're trying to move and load into a machine, it's a really good application for robotics. Quality, consistency and application for like lubricant or for adhesive, it works really well for those types of things to help us provide consistent quality. And then, as Alwin mentioned, capacity. We're a growing business, and many times we're up against it and capacity constrained, and this is where we can break through some of those constraints with some help from automation.
Right. What about innovations in the space? Like I would assume that this is kind of just continually rapidly evolving. What about in the last few years? Is there any major innovations in this space that have happened?
I think the market's kind of moving towards collaborative robots. Back in the 90s, 2000s, a lot of industrial robots were sold. I think nowadays the trend is towards more collaborative robots. But the advantage of a collaborative robot is kind of more suited for job shop. Gone are the days we have long runs of the same product. There's a lot of customization, basically demanded by our customers. So the collaborative robot's kind of, it's, for those who don't know what a collaborative robot is, basically a robot that has, without getting too technical, has some kind of safety features built into it, which allows the robot to operate with the operator without having all the guarding and some of the other protections. So it's a little bit slower than a typical robot, doesn't require the same amount of protection, fences and stuff. So it enables the robot to work with the operator. And the good thing with that too is when it comes to the acceptance of the operator too, if he knows that his job's not become redundant, he has the assistance of a robot to make his life easier for some of the replica work, the mundane type work. The robot works with the person rather than the robot doing all the work. So a lot of the projects that we're seeing success with is a robot, like I would say called semi-automated robotics, where the operator is still involved. We're basically looking to speed up the operator, make his life easier rather than replace the person. So there's been a lot of acceptance by the operator, the guys on the floor, seeing the operators adding value. But to go back to your original question, is that the move in the market to more collaborative robots. Of course, as I mentioned initially, there's obviously new trends with IoT and making the process more visible,
Right.
For the supervisory type roles of the the supervisor on the plant floor. Every single robot that we put in place nowadays is IoT capable. So we measure OEE for each machine that we put in, automated machine, where it measures the quality, the throughput, the speed, the full OEE. So that's communication and that feedback to the supervisory people further up in the chain. That's kind of one of the things that's changed in the market too. Is that visibility of what's happening down on the floor is important. But robotics itself is collaborative, I'll say, and visual cameras, inspections, and that kind of stuff is where the market's moving toward.
Okay.
Yeah, and that's a really good fit with PLP because while we do have some long-run products, we also appreciate the flexibility of some of these collaborative and more innovative type applications where changing over from running one product to the next product is almost just as important as speed running a single product.
Yeah.
We're not large volume automotive business here.
Right.
We're very much about getting the customer what they
Some
want, when they need it.
customization and stuff like that.
That's right. So that flexibility and adaptability is key. I just want to reinforce the point that Alwin made as well in regards to the acceptability of the robotics and automation in their factories. We're a very people-centric operation. And so we are not bringing in automation and robotics to replace people. That's not it at all. We're bringing this equipment into the building to help them, to increase our speed, our competitiveness within the marketplace, safety, quality, as was already mentioned.
Yeah, and I think I've heard you say, Doug, before that we don't necessarily want our people doing these repetitive tasks. We want them to do other things, to use their brain to
Absolutely
more powerful things that these robots can't do, at least not yet.
That's right. I haven't heard a robot give me a good idea how to improve the process yet.
But that does take me to my next topic, which is AI. Obviously, that's a buzzword, and machine learning. If it hasn't, I would assume it's already kind of in the robotic space. If it isn't, it will be there soon. How has that, or how will that change the landscape? Because with, I think, that AI and machine learning, I mean, then you're talking about much more smarter robots or robotics or automation that can adjust on its own without that. Do you see that happening already, or is that coming?
Yeah, the low-hanging fruit with AI is with the camera systems. A lot of the AI is built into, or the machine learning is built into the camera systems. So the cameras are basically the eyes of the robot. So the robot's only going to do what it can see. So with AI built into the robotics or built into the system, it can almost start predict what it's seeing patterns and things where it can adjust. So definitely on the camera side, there's a lot of AI that's built in, that's come standard nowadays with the software that's embedded into the camera systems. And then the other obvious one is on the predictive maintenance, because all the machines are connected now. It makes it a lot easier to do predictive maintenance. So those are probably two of the fastest growing areas in the automation space that's having the greatest impacts, for sure. That maintenance and the visualization of systems.
Okay. What's maybe a common misconception or myth around automation or robotics? You guys want to touch on that?
You want to get this one?
Well, we talked about the big one, which is it's there to replace me and or to replace our workers, and that's absolutely not the case.
Yeah,
That's
in
not
fact,
how
that
we
was my
apply
next
there.
question: was do robots replace human jobs?
No, they don't. They supplement and they support our people. We're not there to, as I mentioned earlier, this is all about helping an employee take away the mundane, repetitive work that it could be bad ergonomics, could be unsafe, could also be very difficult to control quality. So we're about implementing this where it's the right thing for the customer as well.
I was going to add on to that is one of the biggest things we're seeing too is obviously as we put these more complicated machinery into our operations, so does the demand for higher skills. So it's also giving the operators to learn skills, but also there's a negative part of that too is having the right technicians and maintenance people to be able to work on the machines. In the old days, if you need to make a change to a machine recipe, you'll just adjust a couple of levers and things. Nowadays, you have to make a change in the program or the code. So there's definitely opportunities for the operators to learn new skills. But that's good for the operator, but not so good for PLP, because now we need obviously a high level of person to be able to operate these systems. So there has definitely been a shift in terms of what skills, specifically from an engineering point of view, is having those skills to be able to maintain and upkeep the systems. And of course, those skills are very scarce. So that's probably been one of our biggest challenges, dealing with the uptick in skills requirements, to design these systems, to upkeep these systems. That's one of the negative drawbacks of automating. But from an operator point of view, they get to learn new skills, and we try to push everything down as far as possible, to make sure that the operator understands and can make adjustments on the fly. But from a maintenance or higher level, there's definitely additional skill level that's required.
Mm-hmm.
Yeah, I mean, change is hard for some folks, and some people are excited about something new and learning something new, and others dread it.
Right.
And so, but we definitely do whatever we can to help the people and invest in them so that they can feel more and more comfortable with the machinery that we're bringing in.
So in a lot of ways, what we're talking about too is there's a lot of intellectual property and a lot of IP and these, machines and processes and stuff like that. I would assume that there needs to be some protection over that. In some ways, I mean, anyone, certain people can make a widget, but if you can make that more, productively or something like that, there's a lot of value in that. How do companies just in general protect that IP on those processes? Or, how do we, I guess? Especially things when we're talking about these are connected machines, which seems like
I was going to say that's a huge issue for us. Well, not an issue that we can't handle, but one of the big issues you need to realize is a lot of these new pieces of equipment are networked. So there's some kind of Ethernet connections, which means you can access it through a smartphone or something like that. So from a RT point of view, there's been a lot of interaction with our RT security people to make sure that there's the correct firewalls in place. So we actually, in part of our machine sign-off, there's a whole internet security protocol that we go through to make sure that when we sign the machine off, it's kind of correct firewall and protection in place, so no one can access any of the RP. Not only in the machine, but within our local network. So that's been a big issue for us, is to make sure that there's those firewalls and protocols in place, because basically the machine becomes a computer that's networked, and it's the same protocol with any like phone or a computer that may exist within a company, has to be protected within the same firewall.
And it's something that we're always challenged with, is that we want all of our sites to experiment, to move fast, and so that we can find the best solution to a lot of our common challenges that we have. But we have got to be safe and secure with our cybersecurity for sure, because part of automation is the automation of information flow.
Sure.
I mean, having data at our fingertips in our operations has been proven to be very critical in us making the most timely and effective decisions that we need to make in order to protect our deliveries.
Yeah, no, that's a great point.
But going back to in terms of protecting the RP of actual machine design, I think that's one of the reasons why we have a machine design group, to obviously protect that RP, because we have very unique processes in place. So the generic run-of-the-mill stuff you'll see in most factories, we'll outsource that, but the stuff that's kind of protected within PLP in terms of the secret source, we would run those projects ourselves. And when we share drawings to outside companies, we obviously put the right NDAs in place and don't give anyone this, all their prints. We'll kind of break it up into different vendors just to protect the designs that we have in place.
Yeah. So I think one difference between, I guess, most of the robots that we probably employ and humans is that most of those robots, I would assume, if not all of them, are very task specific. Versus, I think, a human is more general purpose. I think there is general purpose, robots on the horizon. I'm not sure if those have an application for us or in the future, or where do you see that going?
So, I mean, the obviously in the media and stuff, you do get humanoids.
Yes.
So there's a place for that, but the development of those, the technology is not as advanced as it should be. I mean, I have looked at certain applications, for example, pick and place. If you have something on a pallet, for example, you want to move it from a packing bay and you want to move it to a pallet, that technology is simple enough to pick, walk, and drop on pallets. But anything beyond that, in terms of doing something that requires fine hand motor skills or anything like that, I think it's a long way off.
Mm-hmm.
So, I mean, it is coming, maybe 5-10 years down the line, maybe sooner. But I think most applications basically pick and place, the humanoids picking something up and placing it,
Right.
loading something, very simple
Right.
applications.
Okay. What about it? So what's something that when you think about automation that we haven't been able to achieve, or any company hasn't been able to achieve yet, but would be kind of like still seems like science fiction, but would be immensely helpful if you could automate that? Is there something that comes to mind?
I was going to say the same humanoids. Just imagine if a workforce walk into the factory and they clock in and they start working.
Yeah. I need a humanoid that does my job.
Yeah, exactly. Yeah. Well, I think everyone, with AI in general, I think, there's all kinds of talk about, how many careers will still exist in 5 years' time, like teachers or engineers. I mean, we're looking at AI and engineering. Some of the 3D modeling packages that we have for designing some of these components really have some kind of AI built into it, where in the past you have to design everything from scratch. With the AI built into the 3D modeling packages, there's a lot of that manual process that used to be done in the past basically is automated. You set the boundaries, or you set the critical conditions, and the AI basically holds up and designs. So I think that's a bigger issue where things are changing with AI in general. So I think that's going to be the same for automation. Everything is going to eventually be driven by AI, and all the decisions will be taken place by machines, not people.
Yeah. One of the other things that I know would be very beneficial to us is automated changeover from one product to another. We've worked on bits and pieces of that, and we've made it easier and faster. But the more automated changeover, so that we can make only the products that we need at the time quickly.
Does that mean like changeover tooling and all that?
Changeover tooling.
Mm-hmm.
We have not been able to break through that on a full automatic, and don't know if I've seen too many other operations do that either.
Not many, no.
Yeah, which can be a lengthy process, right? Yeah. Especially for some companies, like the automotive industry, changing over a line to a new car. I mean, it can take months.
Right. Absolutely.
Well, one of the things talking about CI and changeovers and stuff is one of the, you asked early on about the lessons learned and some of the growing pains we went through is a lot of the time we put in a piece of automation into the plans, and you tend to like walk away. Okay, there you go. There's your piece of equipment, but there's a whole hand holding a process needs to run. And in fact, what we started doing now is normally like a CR project that will run together with that automation. So like things like hand changeover and stuff, it's kind of dealt with from a human system point of view to make sure that it's not just operating the piece of equipment, is understanding. If there is a changeover, what does that look like? If I need to go fetch something, where do I go find it? Because I used to go here to find it, now it's going to be there. And I used to do things like this, and I was like that. So the CI human part of it, that's also been something we try to integrate in the hand of the project to make sure that these new rules are defined. So it's not so much the handoff in terms of the operating systems of the machine as how does the machine interact with the other process we have around it is a huge thing that we learned.
And it's very important as well because I've seen applications of automation where the team will just put it there and leave it and not understand the overall implications of we just took a changeover time that was 20 minutes and we made it a day to change from one product to the next because we made it very complex or very difficult to change over from making product A to product B. And as Alwin mentioned, him and his team do a great job of working with the local teams, the local CI teams, to make sure they're understanding the implications and they're incorporating a lot of their ideas and the automation to consider those things.
Right. So Doug, maybe you can talk to this because you've done a lot of travel in the Asia region. So in some of my research, I think the number I found was that 70% of new robotic installations are in the Asia region. Specifically, I think it's South Korea is the leader. I think China's up there, Japan, and then you start to go down the list. Then you get into some in Europe like Germany. So, United States isn't up there, even though I would consider us, the forefather to some of that stuff, if you're talking about the assembly line and stuff like that. So why is Asia and a lot of those countries kind of the leader in the implementation of these things, and some other countries, developed countries, aren't?
I think it's a little bit of them catching up, as well as that's where a lot of our manufactured goods, global manufactured goods are made. Is in the Asia region. So I think those two things coupled together is what would create a lot more new automation applications in that region. What about you, Alwin?
Yeah, I was going to just add to that is obviously in the U.S. in terms of cost justification makes it a lot easier because the labor cost in the U.S. is a lot higher than Asia. But in terms of gaining capacity, there's obviously a lot of opportunity in the Asian countries since they do a lot of manufacturing. So their focus is more on gaining capacity, where our focus may be more on cost savings. So it's two different kinds of thought process. I know to justify a project, automation project at PLP in Asia becomes a lot more difficult and challenging because the labor rates are a lot lower. So we have to be very clever in looking at low cost sourcing in terms of components, robots, etc. So we've done a lot of work to reduce those costs and that sourcing and supply chain point of view to make it more competitive from a cost standpoint, but definitely more focused on capacity gain rather than cost savings. And US and the Western countries and stuff is probably more cost driven than capacity driven.
Gotcha. What's a process that's extremely hard to automate? I mean, you touched on this a little bit. I think anything that's kind of like super complex or that anyone that has a big mix of products or SKUs or something like that. But what's specifically something that either you've experienced because it's given you headaches or what is just very difficult to automate?
Well, I think the biggest issue with automation is because you have a repetitive task. If it's a repetitive task, it has to look the same. So any time you have variability in the process is when you have issues. So any kind of variability, that's when you start picking up problems. And I know for PLP specific, we do preform line wires, which have a twisted wire, and it's very unique. So ensuring that the upstream process are consistent ensures that your downstream automation is successful or not. So that's huge in automation to have that repeatability in the process. So the process controls have to be very tight because, for example, you may have a robot that picks something up, but if it's in a different location each time or looks different, makes it very complicated to load and have that continuity of operation.
Yeah, just to reiterate that, the variability that we can accept in function is sometimes looser than the variability we can accept in some of our automation, to where the part may function just fine, but we actually have to tighten up the process in order to automate it.
Yeah, that makes sense.
Yeah. So, I mean, it goes all the way up to product design for automation. So we spend a lot of time working with design engineers to make sure that the product is designed for manufacturability, but more so also designed for automation so that the piece can be automated. So those kind of, we don't always do a good job of it, but it's important to make sure that at the product design point of view, there's obviously come foresight in terms of how will this piece be automated or how would it be touched down on the manufacturing floor.
Okay. So let's look down the future, 20 years or so. What does that factory of the future look like? I know we're kind of talking about not necessarily replacing, human jobs, or maybe they're shifted to a different role. But is there in the future a fully automated factory? Is that the future? I don't think that exists right now. I mean, I'm talking nobody on the shop floor. Is that where this would go eventually, or is that even a possibility, or what is the factory of the future?
I mean, talking about lights out factory where you basically turn the lights off and you leave. I mean, I think that's something that's definitely doable, but depends on the product. I mean, I worked, one of my previous companies I worked for, they were a cable manufacturer, and because it's continuous processes, it's easier to have a lights out type of process. I think to answer your question, depends on what type of process it is, what is possible in the future. If you have continuous processes that look the same, behave the same, lights out type factory is 100% doable. Jobbing obviously becomes a little more complicated. I'm not saying that, down 20 years for sure that technology will exist. I would say, to answer your question, I'll say that's very possible that you could have a lights out type operation where you basically turn the lights off and everything just runs itself.
Mm-hmm.
Yeah, I think the key to it is what Alwin mentioned, is that the continuous processes we could be there today, but it's the changeovers, it's the small batch runs that we do for custom products for some customers that make it that big of a much bigger challenge to get there within 20 years. So at least from my standpoint, I still see people in the factory. Their role will shift to be a lot more, as we were talking about, a lot more engaged in troubleshooting the equipment and understanding what's improving on the equipment, rather than doing the physical labor of moving products around. But I definitely see people in the factory of the future.
So Skynet is not self-aware yet.
No.
Safe? Okay. So we're safe from the robots.
That's right.
For now.
It's safe to walk in the factory. It's okay.
Yeah.
Just stay on the aisles.
Okay, so this has been great. Final question that I just have is, if someone wants to learn more about this, is there resources that you guys use? Another podcast, hopefully listening to this podcast, but another podcast, or books, or websites, or organizations that people can learn more about this?
Yeah, there's the RAS Association, so there's robotic associations that you can join. There is certain schemes offered by the federal government where you can learn, and there's programs in place to assist mainly small companies. But I'll say joining an association will be the starting point to guide you in the right direction.
Mm-hmm.
And of course, there's always automation expos all over the place that you can go to.
Sure there are.
Well, there's Automate coming up next month. Automate is a big trade show.
That's in Detroit, right?
Yeah, it's Michigan, Detroit this year. So that's coming in May. Forget the dates.
Yeah.
Okay.
It's the biggest automation biggest automated show in the U.S.
Okay. Great. All right. Well, thank you so much for joining. And everyone, stay tuned for more Connecting the Lines.